Hello, my name is Meister, and today I'll be discussing nuclear magnetic resonance spectroscopy. Nuclear magnetic resonance, or NMR as abbreviated, is a phenomenon which occurs when the nuclei of certain atoms are immersed in a static magnetic field and exposed to a second oscillating magnetic field. When people hear the term NMR, a sense of panic and confusion sets in due to the fact that NMR can look like such a complicated performed. However, the process is broke down by the history of NMR, how the test is performed, and how the results are read, as well as how NMR is used in everyday life. NMR is a very beneficial process to understand. Nuclear magnetic resonance is an analytical method that is used to identify the molecules in a specific sample, which leads to being able to identify the functional group spread. In 1945, NMR was discovered in the U.S. by Felix Bloch and Edward Miles Purcell. The process was first introduced as easy as a substance is placed in a magnetic field. Some atomic nuclei then behave like microscopic compass needles called nuclear spins. After Bloch and Purcell discovered the process of NMR, it was 7 years later, in 1952, that both took half credit for a Nobel Peace Prize in physics. When Bloch and Purcell identified that the nuclear spins creates an orientation that is unique for each chemical bond, the process could only be used for concentrated solutions of fairly small molecules at first, but has now evolved in a very accurate test for many situations. Without the use of NMR and other similar techniques, it would be a hard task to identify the chemical bonds that make up polymers and copolymers. The process is recorded by the molecules that move show a peak on the graph and are associated with a molecular weight, which is compared to the known values of the molecular weight of chemical bonds, thus being able to identify the bonds in a sample. NMR is joined by other tests like infrared spectroscopy, using a Fourier tester and electron paramagnetic resonance, and being great processes to show the characteristics certain chemicals have in random samples, and even being able to identify them. These processes were identified in the lecture for thermoplastics at Pittsburgh State University. The process of testing through NMR can vary in procedure, but the simplest use is referred to as the CW method, or continuous wave method. A solution of the sample in a uniform 5 mm glass tube is orientated between the poles of a powerful magnet and is spun to an average any magnetic field variations as well as tube imperfections. Radio frequency radiation of appropriate energy is broadcast into the sample from an antenna coil. A receiver coil surrounds the sample tube, and emission of absorbed radio frequency RF energy is monitored by dedicated electronic devices as well as a computer. An NMR spectrum is acquired by varying or sweeping the magnetic field over a small range while observing the RF signal from the sample. Once an NMR spectrum is relayed to the computer, a graph is produced that shows the peak points of certain bonds that are affected. These values show the chemical shift taking place during the test to identify the bonds present. When dealing with plastics in the field, it can be useful being able to characterize specific types of materials that may differ from the original sample. As seen here, there are various polypropylene samples. When running an NMR test on different samples, it can be beneficial to see the characteristics that each sample has and being able to use the right product and not creating hazard. When thinking about NMR, one does not think of all the everyday applications that NMR goes into. Almost everyone has had an accident. You fall off a tree, you break your arm, you hurt your leg, you end up going to the doctors, and they put you in an MRI machine. An MRI machine does the same thing that an NMR machine happens to do. For both tests, a magnetic field is applied to the nucleus of a particular test subject, causing specific bonds, or in this case of an MRI, tissue is isolated. Both this information is then read, and the person is diagnosed with a specific injury, and the scientist running NMR can diagnose the bonds in it. NMR has become such a useful technique that there have been very odd requests being made. In 2010, Hendrix College received a grant from the National Science Foundation to acquire a 400 MHz NMR spectrometer to enhance faculty and undergraduate research. The proposal was aimed at enhancing research training and education at all levels, especially in areas of study such as the synthesis of pyrrole-based biologically active marine alkaloid analogous and isotopically labeled porphyrin metabolites, discovering and characterizing of mammalian chemical signals of endangered species like elephants, lemurs, and maned wolves. The discovery of NMR by two gentlemen in 1945 may have been one of the most beneficial discoveries in the past 100 years. Without NMR, it would be very hard to be able to properly identify the chemical characteristics of an unknown sample. Throughout the history of NMR, the process has stayed the same, but the applications have developed into very sophisticated and beneficial tests. from simply testing the chemical makeup of polymers and copolymers to now being able to run tests on humans through MRIs and even using a simple test to try and characterize chemical signals of endangered species. NMR is clearly a very important test with such an easy test and easy data to interpret. NMR should be the go-to test when needing to characterize an unknown material. That is the conclusion of the NMR presentation. Thank you for your time.